Hi folks, welcome back to Math with Captain Rod. I'm making this video here to be video number 2 here in our unit notes over this function stuff. So let's see, it says use the indicated graph to identify the intervals over which the function is increasing, decreasing, or constant. So increasing means as you go from left to right, the function's going up. Decreasing means down, constant means level. So when we look at this function, as we go from left to right, the y value is going from -5 to -4 to -3 to eventually 0 to 2 to 1 to 2 to 4. It's increasing the entire time. So this function is increasing. Whoops. Get my pen back here. On the interval from x equals -4 to x equals 3. And that's it. Let's take a look at let's take a look at this one right here. So as we go from left to right, this function is increasing as, you know, how do I want to put this? X value wise, this goes to -infinity. So when we go from -infinity to the right, the function's increasing the entire time. We can't see that way down here, but it's way down here where the y values are getting bigger and bigger and bigger, like where like this, you know, like -10 is less than -8, is less than -7, and so forth. So this thing is increasing all the way to x equals 2. So increasing from -infinity to 2. From 2 to the right, this function is decreasing. So it's decreasing from 2 to, in interval notation, we'd say from 2 to +infinity. All right. Whoops. Let's take a look at this one. Okay, from -4 to -2, it is decreasing. So I'm just going to put D for decreasing. From -4 to -2. Then from 2 to x equals 4, it's increasing. See how these y values are getting bigger and bigger and bigger. So it is increasing on the interval from -2 to 4. The one on the right. Now, presumably this function goes on forever to the left. So if we think about what's happening from -infinity to 0, this function is constant. In interval notation, we'd say that's from -infinity to 0. It's also constant from, it looks like 3 all the way to the right, +infinity. So let's say it's constant from -infinity to 0, and from, I would say that's x equals 3 maybe, to the right, so 3 to +infinity. Okay, from x equals 0 to 3, the function is decreasing. So decreasing from 0 to -3 in interval notation. All right, let's take a look at this one. So again, look at these y values. See how, like, you know, that's like negative, I don't know, 20 or something, and then, you know, -10, eventually 5, -3, 0, 1, 1.5, you know, 2. I know these numbers I'm saying are not exact, but that value is about 3. This function's increasing the entire time. There's no time that I see that this function is decreasing or constant. So it is increasing from -infinity to +infinity. All right, let's take a look at this animal. And again, presumably this goes infinitely far this way. So domain-wise, you know, the domain of this function, it's looking to me like it's all real numbers. It goes infinitely far to the left and right. And what you have to picture is way out here where we can't see it, as we're climbing, these values are getting bigger. So this function is increasing all the way to x equals 2. So increasing, let's say from minus infinity to 2. Now, once we go to 2, now the function values, see how they're getting smaller? This, then 0, and then negative something, negative 2, negative 3, negative 5. Now it's decreasing the entire time. So this function is decreasing from x equals 2 to plus infinity. Now it says an interval notation. That's what this says. All right, next part of the notes. Graphing piecewise functions. Okay, so a piecewise function, kind of like its name implies, it's a function that changes how it's defined at some value. This function g of x is equal to 2x if x is to the left of negative 1. So here's negative 1 on the graph. It's equal to x over 2 if x is to the right of negative 1. I'll talk about the equality and what that means here in a moment. So if we were to graph 2x, I know that one point is that goes through 0, 0. It also goes through 1, 2. Now, this is a linear function that does this, but this function is only defined to the left of negative 1, so I'm just going to draw it to the left of negative 1. So if I put negative 1 into that, we get negative 2 out. That's this point. I'm just going to do one more. If we put negative 2 in, we get negative 4 out. So negative 2, negative 4. See, there's a little more room here. There we go. I'm going to do one more point. If we put negative 5 in, we get negative 10 out. That's all the way down here. Let's see, negative 5, negative 10. Oops, did this one get in the right place? Negative 2. Negative 1, 2, 3, 4. Yeah, that one's in the right place. This one, negative 1, negative 2. Yeah, we're looking good. Okay. It's a linear function, so it looks something like this. Now, right at negative 1, right, where we have equality, the function is equal to the 2x. So the way we say that on the graph is we put this circle here. That's called a closed circle or a closed dot or something like that. All right, now to the right of negative 1, g is equal to this function, which is x over 2. So this is a linear function as well. I'm just going to plot a couple points here. If I put negative 1 into this, we get negative 1/2 out, so negative 1, 1/2. And you notice I'm putting an open circle there instead of a dot. That's because there's no equality there. That point is technically not on this graph. And then if we put 0 in, 0 comes out. I'm going to plot 1 or 2 more points. Let's use 4. If we put 4 in, 2 will come out. So 1, 2, 3, 4, 1, 2. That's enough. It's linear. Maybe one more. Let's see if we put 10 in, 5 will come out. There we go. Bang. So here is a graph of this piecewise function. The big thing is that you have to graph 2x and x over 2. And g is equal to 2x to the left of x equals negative 1, and it's equal to x over 2 to the right of negative 1. Because the equal sign comes with this function, we put a closed dot at the end of this function, so to speak, and an open dot at the end of this one. All right. More fun. Okay. So now we've got this piecewise function defined 3 different ways. Absolute value of x, if we're to the left of 1, x squared from 1 to 3, minus x plus 2 if we're to the right of 3. All right. So absolute value of x, we've seen that graph before. That thing looks like this. Like so. Whoops. Darn it. Kind of missed my target there. Looking for the back button. Now we'll just go through 0, 0. When you put this in your notes, hit that 0 a little bit better than I did. And then it starts going up and right. but I'm going to stop here because the way this function is defined, it's only defined as this thing to the left of 1, not including the 1. So, boom, boom. From 1 to 3, so that's from 1 to 3, the function is y equals x squared. Now y equals x squared is parabolic. It does something like this. It goes through 1, 1. I guess that's that point right there. It goes through 3, 9. I'm going to put an open circle on that because we're not including 3, and it's parabolic in nature. So it kind of got some curvature to it. All right, to the right of 3, we're equal to negative x plus 2. This is a linear function. If we put 3 into this, let's see, we're going to get negative 1 out. So 3, negative 1. Close dot because this is equality. And I'm just going to put another value in, like negative 10, or I'm sorry, like 10. If we put a 10 into this, we're going to get, if we put 10 in for x, we get 8 out for y. Oh, I'm sorry, negative 8 out for y. So 10, negative 8. Linear function, so we're going to connect the dots. All right, good enough. So when you fill out your notes, please be sure though that this point right here, that line should have went through that point right there. I just couldn't find the back button here to redo that. Like it goes through 0, 0, negative 1, 1, negative 2, 2. I missed that just slightly. I should have plotted a few more points. So that's good enough. There's a sketch here. Again, this is y equals the absolute value of x in this region up to this point. From 1 to 3, the function we want is x squared, and from 3 to the right, the function we want is this guy, negative x plus 2. So you put all these things together, and we're looking at a graph of a of x. This function defined different ways throughout the graph. All right, and we are, let's see, at minute 12, so I think I'm going to go ahead and stop that right there. You can take a break and grab some popcorn.